Hello everyone, and in this video we are going to see about the voltage injection and what are the factors in voltage injection and how to do it perfectly, and what are the equipments you need, what are the things you need in voltage injection. So basically, what is voltage injection? The thing is, if some component getting shorted, then will be finding a way. That way is called voltage injection. So if you're having any SMD circuit or SMD circuits like this. So this is a SMD circuit. So you can see plenty of components, and this is SMPS. You can see the components. So in such cases, what will happen is some component will getting shorted. Like for example, if any capacitor or any diode or any resistor or something, anything will get shorted. At that time, you can easily find that shorted way using voltage injection. So there will be a multiple ways of finding the shorts in every PCB circuits. Like I was using rosin before. Then I moved to thermal camera, so which will easily identify pinpoint where the problem is. So this upgradation makes your work so easy. At the same time, if you are good enough, you can just using rosin. That will be fine enough, because if something happened in some particular component in SMDs, that will reflect in another way of another component. Like if you are getting a shorted component right here, like I'm saying, I'll just imagine this board is having full of SMD components. Okay, so if you are getting a component, bad capacitor here, it will be reflecting here or here, something else, somewhere else. So what will happen is this capacitor is connected to multiple points. Okay, so that will also getting shorted. One component is enough to short everything. Okay, so that is the way it is working. So what are the procedures to find the shorted component? And as I said earlier, you can use rosin, because a lot of videos I was using rosin before thermal cam. Now I'm having thermal cam, so it will be very easy to me to figure out which component it is. But at the same time, you have to get some knowledge regarding this, because sometimes what will happen is you will be getting shorted here and here. So both sides you will be getting short. You'll be getting the beep sound in whenever you are using multimeter with the continuity mode. So make sure you are doing good, and you are doing with sense. So that is a necessary case. And what else? So this is a basic thing. What I'm saying is this is a basic thing, and there is much more regarding this. And let's see about the voltage injection and how to find the shorted components, and what are the factors like voltage fluctuations, or signal failure, or any preferably it will be like the voltage in this shorted component will be coming after voltage fluctuation or something else. So in this video I'm showing you that how to find that shorted components using multiple resources. I have rosin, I have thermal cam, and we'll see it. I'm Praveen Rajagopal, and this is Mr. Biomedical. cool. Um, Earlier, when I started my career, I was, I was very curious about this SMD and SMPS because I've seen a lot of videos. I've seen a lot of videos, and I've seen so much people's doing the SMPS things. So at that time, I was very curious about it. So that is what it pushed me further to learn to learn the right things and to learn the particular basic things. So if you are a beginner, you have to make your foundation so strong. Then only you can proceed further. So furthermore means you can proceed even more than anything else. And your hand will be shaking initially. Your hand will be shaking, and your eye will focus something. You can have some headaches or something. But apart from that, if you wanted to learn something, you can learn, and you can expose yourself, and you can go further. You can go on top, and whichever is possible. And now in this video we will see how to find the shortcut component. So this is a basic way. What I am telling is basic way of doing SMD things. Okay, so wait, let me grab some board. Okay, we'll start with simple board. Okay, and I have capacitor. Okay, I have this board. So it's a simple thing because there is nothing in backside. So only one area will be covered in this particular board. So what I'm going to do is just short one component and see where it will be reflecting. That if we are shorting here, and we will see where it will be reflecting through the components. Okay, so first of all we will learn this, and then we can go with voltage injection.
So now we are seeing the single layer board, and this is a single layer SMD. So seeing it right now, there are many components. You can see this is a resistor, R for resistor, and U for IC, and C for capacitor, and D for diode, and yes, this will be U, and okay, much more. Now how the short happened, if something some volt drops, or voltage fluctuation happen, then at that time it will happen, this fault is capacitor or something will happen. So for example, I am starting this capacitor now, right? I'm starting this capacitor, and then we will see what are the points we are getting short. Right. And flux, or else we can do one thing, we can just apply the lead here. Oh, oh, oh. Let's just assume that this is a capacitor, okay, shorted capacitor. I removed the capacitor. Okay, cool. Just assume that this capacitor is bad and shorted. I'm taking my multimeter now. Put it in the continuity mode. Okay, I'm okay. Having short. So this is a shorted capacitor. Okay, just assume that. Then we will see one by one for shorted or something. So if you are good experienced, you can just go through the random things, and then you can understand where the problem is. And this board is only one short, so there is no hidden circuit from that capacitor, I guess. So maybe this IC will also get heat. Oh, 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 oh. Yes, yes, we got a short here, right here in this board. Here, okay. So as I already told you, the short, affecting that short affected this one, this particular capacitor. So in this case, what you have to do is, if if two or more short is happening, or two or more shorted components, you should use voltage injection. And I'll tell you how. Right, let me show you. So I was using with rosin, and now I'm not using rosin at all. Wait, let me search my rosin first.
So I will tell you clearly. First I shorted the component here, this one, okay, and then the short was reflected here. So if you are getting two or more components at the same time shorted, you should use voltage injection. Okay, by that mode only you can easily identify which components getting short. Then you can easily find out where the problem is, and you can change that capacitor and make this work, make this board work. So let's find out how. For voltage injection, you should use 1 or 2 volts in your DC supply. 1 or 2, yeah, maximum 2 volt is enough, and that 2 volt must be injected in the positive side of the capacitor, and then that negative side will be, negative point will be in the negative side. For example, if you are okay, can you see this? Yeah, if this is a negative line and this is a positive line, means what you have to do is just put the negative lead here and positive lead here, and when you touch it, if you are using rosin or if you are using a thermal cap, it will reflect what is the heated point. I mean that shorted component will be heated. So at that time you can easily see where it will be heating, and where the exact spot, heating spot. That heating spot will be the shorted component. So you can easily find what is the shorted component there. So here I am using just a jumper, and I'll show you the live demo so that you can understand. Okay, here you can see. This one I shorted there. So assume that this is a capacitor, okay, and the reflection was here, C28, shorted. So in this case there are 2 shorts. So what you have to do is just inject the voltage in, wait, let me show you. So if you are using if this is a minus, okay, if this is a minus point, you should you should place your negative lead here. I mean DC power supplies a negative lead here, and put the positive lead here with 2 volt or 2.5 volt, whichever it possible. I mean whichever the circuit will rely on it, okay. So once you inject the voltage here, that heat will be shown here. So that is a point. That is how voltage injection works. So I've posted a lot of videos regarding this. So you might have some basic knowledge about that voltage injection. But some case, okay, in some case this is a purposely I did. But in some cases, what will happen is, even if you're turning on your machine, the component will automatically heated. So at that time also you can easily see that video also I posted, this Bistos BT350 video. You can see it for fetal monitor. That fetal monitor, when I switched on, and at that time only that comparator or something shorted, and it showed a heating spot, and I was using that rosin. So here I am not using rosin or thermal cam anything, but I'm telling you how to inject the voltage, okay. So you will here, if this is a negative, you will be placing your negative lead here, and you are going to placing the positive lead here. At that time, and what you are going to inject is 2 to 3 volt or 1 to 3 volt. No problem. There is ampere, doesn't matter, and only voltages matter. So let's assume it is 3 volt. Then what will happen is that 3 volt is going into the circuit, because it is a shorted circuit. So it will go around and see where the shorted component, which is a shorted component. If it is not a shorted component, it will that electricity move through this thing, through this capacitor. So there is nothing happened, like there is no heat, or there is nothing happened. Then what will happen is, this one is a shorted one, so the positive energy will try to go here, but it will fail. So at that time, what will happen is, this component will get heat. So that is what this heating feedback is coming to our site. Okay, like if you are using rosin or thermal can or something, it will be showing in that particular thing. I think this is a basic one. Maybe tomorrow or day after tomorrow, I'll be showing you the real demonstration. This is a basic thing which I told you earlier, and this will be enough for basic things. But I will give you the live demonstration. Once I get the shorted board, or shorted component or something, I'll show you the real video. So you are seeing the one-sided SMD board, and only there were only two components are shorted, but I was telling you as an example. So if you are getting only two short in particular board, you don't have to worry. You can just remove two components and change both components, and that will be fine. Sometimes what will happen is, the circuit will be interconnected to 5 or 6 capacitors and one IC and one resistor or something else. At that time your voltage injection will be perfectly working. Like if you inject the voltage in particular place, it will be showing the feedback in another circuit. So at that time, you can feel the heat there, and you can find the hotspot there. You can easily figure it out, and you can easily pinpoint that exact component. So this is how voltage injection works. So hope you understand this video. If you are not, you have to go the entire video. Even if you are not understand this concept, just message me in comments, or I gave my WhatsApp number and I gave my email ID. You can just write a mail, so that I can explain you more than you think. So that's it now. And if you're happy with this video, like and subscribe, and don't forget to subscribe. And if your friends seeking for any training or something, you can suggest our videos that will help them to learn the basic things, and I can make sure that you will learn something from me. So that is what I'm initiating the process of teaching something to the beginners. So I think this video will help you. Hope you like this video, and we'll see you soon with another video. Thank you so much. Bye bye. Well, in this repairing video, we're gonna be working on this board, which came in from Kerala. So customer told the board is not working, and please do the needful. And I can see nothing with my bare eye. So what I'm going to do is just check under the microscope, and I have multimeter, and I have a thermal cam, and I have a DC generator. So that will be fine to identify whether the problem is here or not. So and problem is here actually, because customer already told they cross-checked with another machine, and that board is working. So there will be a chances of any components damage or something. So So here we go. We'll go to find the problem. And I am Praveen Rajagopal. This is Mr. Biomedical. So, in every SMD or SMBS board, you should know where to start. And the thing is so simple. Whenever you are starting with the board, you should start with visual inspection, like for any damaged components or missing components or blown components or any corrosions or any liquid damages or any track failure. So there is so much of chances over there, so you should see visually, then only you can understand the PCBs. So this is a formula of every PCB, and I'm doing every time. So this is two-layer board, and one layer is here, you can see, and another one layer is here. So here having the microcontrollers, ICs, capacitors, resistors, and diodes, and LEDs, and inductors, and everything. And here I can see only capacitors and resistors. We'll see under microscope and what's inside, and let's see whether it will work or not.
So let's see. So this is a IC, and this is a connector, female connector, and this one is resistor. I'll show you. This is a series resistor, I guess, and this one is inductor, and resistor. This is a dip switch. This is resistor, serial resistor. Maybe it's fuse, I guess. Let's check with multimeter so that I'll also know whether it's a resistor or yes, it's a fuse. No, it's not a fuse. First one and last one showing continuity, and another two is showing no, it's a fuse only. Yeah, it's a fuse. So if a maybe, and then I'm searching for broken components or blown components, but here caps fine, and resistor is fine, IC is fine, capacitor is fine, inductor is fine, resistor is fine. I can't see anything obvious till now. Maybe some corrosion here, but that doesn't matter. It's still in track, so don't worry about it. Resistor is fine, and IC and IC legs are fine. Here also fine, and here inductor, capacitor is fine, comparator is fine, so everything is fine. opposite side. Capacitors is fine. Resistors is fine. Capacitors. Okay, absolutely fine. So what I'm going to do is just check with the multimeter and see whether we have a clue or not. So I'm taking my multimeter and put the multimeter into continuity mode so that you can understand if there is any chance of short or something. So now it's in continuity mode. I'm checking it one by one. So whenever you are check, now it's showing 1.259, which is good. Oops, oops. This one is inductor, fine. Oh, this capacitor not fine. 20.8. 20.8 means it is a half short, and here 20.8 same. So this is also had a half short. So here nothing. Here 21.6. Here 20.8. Here 20.8. But this color is changed. I don't know why, but these three colors are same, but this capacitor color changed by any type of heat or something. I am suspecting this gap, uh, but let me check. We will do with one thing. We can do with the voltage injection here, and then we can see where the problem is. So if the problem is found, we can have a same capacitor, and then we can proceed further. So now the question is whether we can do or not. So we can find this the problem or not. So let's work on it. Yes, yes. This one is 0.4776, which is absolutely good. This one 20.8. 1, 2, 3, and here and here. 1, no, here, no, here. 20.8. Totally 1, 2, 3, 4, 5, and 6. No, 3, 5. 5 capacitors showing short, but okay, this one also. So 6 capacitor showing short with a name with the same number like 20.8, which is not good. So we'll go directly for voltage injection and see whether it will work or not.
Okay, here the fact is what is already happened is 1, 2, 3, 4, 5. No, 3, 4, 5. 5 capacitors showing shorting, and this one also showed short. And the before injecting the voltage, we should know where we have to fix the negative line, because that is a major fact whenever you are doing the voltage injection. So here I am with negative voltage, and here I am with positive this one positive lead. So where we have to inject the voltage, that is a special point. So if you don't know where to fix it, then it won't give you the hotspot. So be careful on it, and once you done, you can easily find out the shorted components. If you're not placed the leads correctly, then what will happen is another components, any other components may damage by these voltages. So be careful whenever you are dealing with the voltage injection. So now what I'm going to do is put the negative lead into any capacitor negative, because capacitor negative will be connected through the everything, because through the every components. So I can put my negative lead here, as you can see. And now what I can do is just give the positive lead to positive lead to any capacitor here. Okay, so I'm setting my DC power supply to 3 volt. So basically 3 volt is more than enough. Yes, your multimeter also giving the 3 volt to measure the diode values and capacitor values and everything. So it doesn't matter if you are choosing 3 to 5 volt, and I'm setting 3 volt here. So that will be more convenient for me. So now let's check with the voltage injection. And the point is, you should know where to put the positive lead. So that will make you to understand, or make you to have a conclusion with which is the shortest part. Okay, and I'm having my thermocam here, so I can monitor where the problem is. So that is another way. Okay, so now you can clearly see. So what I'm going to do is just put the negative lead in any capacitor's negative line, and inject the voltage in here, so that we can find which one of this capacitor having short. So after that we can find out. First I have to fix the negative lead here, and put the positive lead here. Okay, so now it's a time to check. Yes, I have a heating spot from here, from that component itself, here itself. So unfortunately I didn't have my rosin. So if I have a rosin, I can pinpoint where the problem is. So let's assume that this component, this capacitor having a problem. Okay, so we will remove this and see. We will remove this and see whether the short is coming or not.
So first we'll put some flux here. Okay, and then I can take my soldering iron and remove Actually, it was the second one, which is getting a hot area, so I'm focusing on second. That's it. So if you think it's the hardest way, so then you should need experience. So these are coming by experience, not after seeing one board or two boards, not like that. There you should have some experience, practical experience, so that you can understand where the problem is and how to do that. Okay, now let's check again for the short. Now let's switch on multimeter, put it in the continuity mode. Okay, now check. Yes. Okay. Go from here. 0.109, which is good. 0.109, which is good. And here also no short. And here 0.412, which is absolutely good. My work is done. So as usual, we should clean the board. Where is it? So be careful whenever you're dealing with SMDs, because sometimes what will happen is if you overheated, or if you um, if you overheated or over pressed pressed this one, this some track, then it will move out. So it will make you a difficult point whether we have to restore the track. So that will be more difficult than it looks like. And now the problem is done, and we should check the capacitor's value, this capacitor's value, and put it here, because these four capacitors are also having the same value, so it doesn't matter. And I am going to measure this capacitor's value and put it here, then the problem might be solved. And customer, if you are seeing this video, your work is done, and I'll make sure that I will get this capacitor and send your board very soon.
So alright for now, and we got the point of where the problem is, and the bad capacitor can be changed because there is a four capacitors, and four capacitors having a same value. So I can easily measure one capacitor's value and order two to three capacitors, and if it is coming, then I'll fix it here and send back to my customer. So alright, that's it, and thanks for watching. And if you like this video, please like and subscribe for more videos, and we'll see you soon with another video. Bye. So here we have harmonic scalpel, which is from Ethicon Endosurgery. So Ethicon is a good company for harmonic scalpel and surgical sutures and all. So what the problem is, let's switch it on. The problem is display is not coming, and even if it is a display problem, the sound will come. Okay, so the sound is not coming and display is not working, so it means there's a problem in main board. We should see the main board. And what else? Let's open it up and see what's inside. And I have my thermal cam and I have my microscope. Let's see inside and see whether it will work or not. I'm just trying that. If it is worked, then fine. If it is not, then I can learn something inside electronics. So this is Ravi Rajagopal and this is Mr. Biomedical. So this is a machine. You can see the display is blank and volume button. And let's, for example, I'm touching the buttons, but it is very quiet. That means the machine is stuck somewhere. So let's open the machine and see what's inside. Let's switch off the machine and open. So basically how the machine is working, if you don't know, the frequency is is a factor. So this frequency we can set the frequency. After that the hand pieces, one piece is permanent and another one is movable. Like what actually happen is the two things, one is movable and another one is stable, and when we set the frequency, it will vibrate, it will go forth and go front and forth. So what will happen is it will make a fraction between this thing. So this energy will be converted to heat energy, so that will make the tissues cut and coagulation makes easy. So this is a concept of harmonic scalpel. So various bloodless surgery can be done with this machine. So I'm already opened the machine. Let's see what's inside and what are the parts there. So first of all, it is the SMPS. That means it will convert the AC power to DC power, and that DC power will be coming to the board. After that there will be capacitors, resistors, inductors and transistors and microcontrollers and much more, resistors and diodes and everything. And this is a speaker, and this is a connecting cable for display, and this is a control cable for display. So no, this is a control board cable, and this is a display board cable. Okay, let's remove safely. So whenever you are dealing with these things, you should be very careful, because if you break anything, then you will be under serious condition. So let's open it up. When I turn on the machine, this exhaust fan was running. So I hope we can make it ready, but let's see. So this is a main board. Okay. So this is the main board, and we'll inspect any visual damage is there or not. Seeing with the mobile, we can't analyze where in case of any blown components or missing components or something, but here, as my knowledge, everything is good. I can see some rust, corrosion over here, but will this one, and no more. I think it's good. Other than that, okay, let's see under the microscope and see what can we do. And I hope this corrosion may make the issue. Let's see it's a corrosion or not. Okay, whatever. We'll see under microscope. And find out where the problem is. And every component seems good. And it is a multi-layer board. As you can see, there's a components behind the machines also. So what I'm going to do is first check if there's a shorted circuit or not. Then we can have a conclusion. If the shorted board means work will be done easily, but if the board is open, we have to see and we have to check with every single circuits. That may not be possible now, but anyway, we are doing our best to up this machine. So hope for the best.
So this is a board, and we are seeing diodes. This D for diode, and this resistor diode, capacitor, and we'll do a physical inspection. If there is not, we can go with multimeter. I'm not seeing anything obvious, but that's fine. That's also fine. Good. Um, it's good here. Let me check another point. So basically, if you are dealing with SMD, you should be really, um, you should be calm. Then only you can make a decision towards them and make the possible ways of work. So here it is, and you should have normal sense, and you should have um, the power of um, finding the component. So sometimes the board will make the short, so that will be very easy to identify where the short is. But in this case, it is not short, I guess. So maybe some broken components inside that that makes this issue. But I'm not seeing anything obvious. So anyway, I'm going to check one by one so that we can have a conclusion that whether it will work or not. And this one I said, and what is this? The corrosion or what? That is good. So we don't want to worry about it. Okay, we can do one thing. We'll take our multimeter and see where the problem is. I'm taking my multimeter, put it into the continuity mode, and I'm checking. Okay, I'm finding something which is here. Here you can see, and it is a transistor, and this one is diode, I guess. See, both side having short, and it is showing 0.00, which is not good, and here 14.1. So something is happening inside, and here also on this side. Oh my god, oh my god. here. This one. This one also shorted. So what to do? 14.3 here also. Uh, okay, let's inject the voltage and then we can understand where the problem is. Yes, it is having shorted capacitor, which is not good. Maybe this will work or maybe this won't work. And here also I got one shorted capacitor. Nothing is fine. That is fine. Here also. Okay, in this section I'm getting a full of capacitor shorts. So we can check this section, entire section. So what I'm going to do is just inject the current and see what is happening. Okay, let's check with our thermocam.
After checking the board, I found nothing on thermal cam and something. So what I'm going to do is just run the machine and going to see under thermal cam. So I think that may works. So go to settings and yes, cool. Let me switch it off, switch it on. Our machine is on and the fan is spinning, and we'll see. As you can see, there's a lot of hot spots and one is overheating. This particular IC is overheating, that is U29 as you can see. So I'm going to order that IC. After that only we can know whether the machine will work or not. So as of now, I'm identifying the problem with this and this. This IC are very hot. So now I'm going to suspect this one, but I don't know whether the problem is with this one or maybe with another component. But the fan is spinning and the light is coming, so and machine is getting on. So that's it for now. Actually I was trying to figure it out where the problem is and within the component level, and unfortunately I do got the heating spot in only one IC. I mean that surrounded IC, 1 2 3 4 and 5 hotspots there, but what is the major part is one IC getting more hot. So what I'm going to do is same that IC are same, so I need to order one new IC and put it here, and we can check whether it will work or not. So if you already attended this complaint regarding this same problem, you can tell me in comments, and that's it. um, I don't know what to say, but still I'm satisfied with this work. All right. I hope you enjoyed this video, and like and subscribe for more videos. See you soon later. Bye bye. So if you ever encounter this problem, like the report initializing, then there's a trackball and left click and right click. Okay. Yeah, first thing first, we should go to the setup mode. From here you can find setup, click setup and go to acquisition. No, not acquisition. Go to system. Okay, in system you can see service in lower menu, and there you can see patient database repair and restore. So first step is you should repair. So it is going and it is loading. So this is the first step whenever you are having the patient database file initializing problem. And if it doesn't work, we can go with other steps and process. And if none other tricks are working, you should change OS. Okay, so now it is processing, and you can say fail to repair. So fail to repair in the sense we can go multiple times by restoring and repairing that things. And I'm also going with hard disk tools in that same step, like repair and restore. But this complaint is not with hard disk issue. It is with only patient database problem. So now it is loading, but I definitely know it won't work because the problem is with OS, corrupted OS or corrupted patient database like that. So for corrupted patient database, we tried patient database repair, but it doesn't work. So we will go to next step. Even it won't work in hard disk tools, so it is unnecessary to go to the hard disk tools unless you are getting the error messages nearly hard disk, so it won't work. Okay, we'll see step number 2 after this one, because you have to know when you hit this button what will happen. You have to know, right? So nothing gonna happen. And okay, now return and repair disk if necessary, but in this case not necessary, but still I'm doing it because you guys have to know what will happen after that. So let's fasten up and see what has happened after this process. So after this process, it will show shutdown option, and we should shut down the device. So click shutdown, and it will be getting off. And after switching it on, the problem will be the same. So it doesn't work in, I mean, some cases hard disk recovery or restore will not work, but the patient database repair and patient database restore will work. So it depends on which complaint you are having, and in this case we are having uh, a patient database complaint. So we should try with patient database repair, but if it in case of not working, we can go with another step. So i'll I'll say what is step number 2. So beginner biomedical engineers don't know how to handle this machine, so that is why I'm telling you, uh, clearly that every machine we can easily go and find for the repairs and what's the issue, and everything. But sometimes what will happen is, your fear overtakes you, and it won't make you to lead anything. So be careful, don't fear, just go for it, and you'll get some good experience from the machines, and after that only you can learn something, and you can go with your flow. So now the system has restarted and Philips logo came. Let's see, we can enter patient setup. Press clear view 350, release 3.2. So in release 3.2 we can go with internal software reinstallation and internal software repair. Okay, now I'm pressing the patient button, and you can see the same error message. The report package is initializing, so we can't give the input of the patient. Okay, let's move to step number 2. So here the same setup, and go to system and go to service. There you can find test and utilities. So there you can see software and maintenance, and then you should click reinstall application and then press OK. So the process has started, and it will be like 228 process, and all the process will be uninstall and reinstall the same package. And if you okay, make sure your preset have been backup, because sometimes what will happen is, this software installation may get corrupted, and if it is corrupted, uh, we have to reinstall the software externally by USB or CD, something like that. So at that time, you should need is preset after the installation. So make sure you backing up everything, and this process will take 1 to 1.5
hour. So in the meantime, there will be a lot of switching on and switching off, booting, rebooting process will be going on, so don't panic after seeing that. So I'm speeding up the video. So now we will get the message system will be automatically reboot, and system is automatically rebooting to its original state. And after that we can try enter patient details. So if it work, we did it. Even if doesn't work the step 2, we have to go with another step, that step which is more important. That is, we should put OS from the outside using USB or something else. So hope it will work. So let's see. And in between you will get this message, don't cancel. You just click OK. After that, proceed, because if you click the cancel button, the uh, machine will make it serial number like 0000, something like that, so it won't work. Okay, now home screen came and every transducer is working, and presets no need to be installed, and you can see one box or left side. That means the machine is working good. So now just put patient details and try. See, when you put patient details, it will come. So that's it in the video. And keep in mind, in every Philips ultrasound machines you can do the same procedure. If you have urgent urgent scanning of any patients or something, and you are in front of the doctor, you can try this confidently. So they will have a good respect on you after this one. So it is especially for beginners and intermediates. Hope it will work, and hope you enjoy this video, and we'll do something else in the next video. Subscribe for more contents, and if you have any questions, comment below, and see you soon.
Right, here we have a ECG machine which came in for no power. So the model is Nidec, and it's a 3-channel machine, and the problem is with power supply board. Because how to tell whether the problem is with power supply or the main board. So it is very simple. If you there's two indication here, one is AC and one is battery. If both are not blinking, or it is not coming, then you can assume that power supply board issue. And before power supply board, before you going with power supply board, you should make sure the fuse is working good and the circuit is good, and some parameters like fuses and NTC, varistor or something like that. So that is a circuit protector, and make sure everything is working good. So in this case, we're gonna open this machine and see what's inside and how that PCB looks like. And after that, we will see how to rectify the problem, and whether it will be working good or not. So let's see. Now we open the machine, and I'll tell you one by one. So this is the power supply board, because the 230 input is coming here, and the processes are here, and then it will give the output. This is some 12 volt or 24 volt or 8 volt, 9 volt, something like that. So it will go to the main board. This is the main board, and this section is called acquisition section. Acquisition means it will get the signals from your body and convert to the graph in the machine. So it will be the main module, and this is acquisition module, and this one is printer. This, as you can see, this is a printer, and this one is LCD drive, and here you can see the LCD and keypad PCB, and this is the printer. Okay, so this is the basic parts, and now we are going to check what's an issue. So as you can see, we didn't get any LED indication or something. So I just open this power supply module, and after that we will see where the complaint is. So I'm removing the power supply from the machine so that we can get a full access to repair. So for the beginners, I will tell you the secret. If you have a problem with power supply board, just go with a visual inspection, because 70% of board complaints, power supply boards, can be repaired by only visual inspection. So you have to know how to visually inspect that, and after that you can use some multimeters things, and you will succeed. So this is how the PCB looks like. Okay, so now I'm folding up the ECG machine, and right, we are just going to work in this PCB, and the requirements are the multimeter, soldering iron, and some screwdrivers, and something like that. Okay, so now the first procedure is always visual inspection. That is what I am always doing, and that is what all the electronics engineers are doing in the worldwide. So first thing first, they will see, is there any visual inspected, any parts damage or something. So as quick as I can see some damaged IC here, damaged transistor or damaged IC, something like that. So as you can see, 1 2 3 4 5 6 pins are there. And the thing is, we don't know the value of this thing, because it blasted, so we couldn't able to see the value of the transistor. So what I'm going to do is, let's remove this one and desolder from here. After that, we will see whether we can have any IC in donor boards. So we have a lot of donor boards, and if you need any donor boards, or if you need any spares, or if you need any components, you can directly WhatsApp me, and I'll be guiding you every time. And we are going to open our own shop very soon. In that shop you can see a lot of items which I'm using, and a lot of the multimeters and microscopes, and little components, and whatever. So now I'm going to switch on my soldering iron, so we can remove. Okay, so okay, it will heat, and before that I will tell you the major parts in any power supply board, so that you can have a little idea about how it works. Okay, so this is a input maybe 230 or 110, depends on which country you are living. So this is a socket, and this is a fuse. How to remove? You just pull, and boom, you can see two fuses, and I already checked these fuses and it is fine. Okay, so in this case, if you are getting this fuse keep blowing, you have to check the circuit protector. And what are the circuit protectors? And this is a varistor, and this is a NTC, and some fuses. So these are the circuit protectors which you have to always see, which you have always look up. After that, if you have some short circuit in bridge rectifier or capacitor or something like that, then also the fuse will blow. So and this is a primary side, and this is a secondary side. So in case of secondary side shorted, and primary side is fine and secondary side is shorted, you can easily see through the visual inspection, or else you can easily use multimeter to test which component gets damaged, or which component opened or shorted, something like that. So it's so easy. So first thing, we should remove this IC from the board. Now it's a cleaning time. I should clean this one properly. I'm using NC thinner for cleaning the boards. I'm using it in both SMD and SMBS repairs. So you choose yours and make sure every pad is having proper connections with the board. So as I told you earlier, I'm having the donor board here, and you can see some type of transistor over here. Wait, so it looks like same one, so I think we can use this one. And here also 1 2 3 4 5 6 pins. So let's remove this one and put it here, and see whether it will work or not. Okay, now we removed this transistor IC whatever smoothly, and this is top 249YN top switch. So I don't know whether it will work in that board, but still I'm going to try, because it is the only way, it is the only guess I have now, because that part was completely damaged. So we'll put this into this board and see whether it will work or not. Okay, now we connected the IC here and solder the legs, and that's it. Then we can check whether the machine will work or not. That's it, it's all over. Now we can see front back, and okay, now we connect this to the machine and see whether it will work. If it is not working, then we can do the alternatives, and I have this module, so we can alternate that, don't worry. So now I'm going to check this board to the machine. So now back to the connections, and then it is more simple connection. One is input and one is output, that's it. Output connections here and input like this, and hope it will work. Let's see, where is the power cord? And Okay, I have a power cable here, and let's fix here. Make sure every connections is not loose. Sometimes the blast will happen because we don't know whether that IC what we put is right or not, right or wrong. So sometimes it will get blast. So get ready. See, you hear one sound, click. And no damaged component here. How about fuse? Remove everything and remove fuse. Fuse is fine, and the fuse also fine. So now we are going to second method, which I'm going to use this one. This 5 to 24 volt variable volt, and having 4 wires, one input and one output. So I'm fixing it here, and then we'll see whether it will work. So I hope it will definitely work, and I've connected and several monitors and several power supplies, and the result was good. So we can believe that this thing will solve this. Let's see. So here connection is so simple. I will explain you. It is so like this. You have to connect. You can see red and black wires. Black wire is going to capacitor minus, and red wire is going to primary coil. Primary coil is coming from here and ended up in here. So in this side, before diode, we should connect red wire. So after that, yellow and blue is going outside. So output means we can connect it in, we can connect it on the capacitor or to the direct output. So in this case, we are having, in this case, we can easily connect here directly. So doesn't matter where we are connecting, but output will be the same. So practically do it. I should connect the red wire here and black wire here. Black wire to the capacitor negative. So I'm going to fix it. That's it. And the other two end, yellow is positive and blue is negative. So yellow is here positive side, as you can see. This is a positive and this is negative. So yellow is going to positive and blue is negative. That's it. So it is the easiest diagram, and we can easily get the output from here. Okay, now I reduced to 12 volt by using this potentiometer here. As you can see, 203 is a potentiometer, and now the bulb is not blinking and the stable output is coming, I guess. So let's see from inside. Before that, make sure you have a room for this module. Check whether the machine is getting on. Same thing, and the light is blinking. Let's switch it on, and yes, that's it. Machine is getting on with no error and without screen flickering or something. So machine is good. So now we have to make a room for this one and close the machine. That's it. Hope you enjoyed this video, and this is how the problem we have to solve. And this is how, and in electronics there is a lot of way, there's a lot of alternate ways to resolve the complaint. So it is all upon you, because you have to decide what are the things you should utilize for yourself to upgrade yourself. So this is my level of repairing, and the machine is working good from today night, and tomorrow morning it will be running to see the feedback from the boards. So if you have any question, comment below, and we'll do something else in the next video. Bye.
So in this video we are going to see about the ECG machine which came in for two complaints. One is battery is not charging and another one is display is not responding and display is not coming insert. And I'll insert my power plug. And as you can see there's three indicators, but it is showing one which is AC and this one is for battery center one which is not coming and another one is battery. So only one light is on. So this machine is working in AC. Let's switch it on, but there is no response. So let's remove the main board and see what is happening and if there is any shorted circuit or something, and remove the power plug. Basically, if the display is issue, there's a possibilities of two things. One is display itself, and another one is display driver board. Maybe sometimes it will be in main board as well. And first, what I'm going to do is just open the device and take the main board out and see under the microscope for the battery repair, battery charging repair, and then we will do the display issue.
Okay, first thing first. So this is the main board, and this one is the battery connector. The battery connector, and yes, we have control fuse. So this might be an issue. This is the battery connector, and one is for feedback, and another is fast and negative. And thoroughly, something. Let's see, not this. There is no ball marks and components. The book. There is no correction. Let's see after fixing that fuse. And a fuse, if you have no fuse, you can just short it out and it will be fine. So that's when remove this long fuse and apply some cuts.
So flux is a major thing. Dealing with simply moving or replacing whatever. Flux is a major thing. Other statement flux is this. The board. So what I'm going to do is just sharp with the wire. So doing any trouble will be fine. The calculus. Is the continuity now? The multi-regular. And now problem with the battery issue. Let's solve that is. Alright, now we put the power plug on and see what will happen. And yes, we have lights on both sides. See clearly. Both the lights are on. So the problem with battery charging is finished. So now what we can focus is machine doesn't responding, and when I press the start button, when I press the power on button, it's not responding. The screen is black. So before that, I need to check because they use this machine last like 7 to 10 months ago, and they said company people wants to replace the entire main board. That is why they are approaching me, and now we will see, and we will remove this keypad and see what is inside, because this sometimes what will happen is in this type of keypad there will be a corrosion or dust will be there, that will make this issue, because the key is not responding. I guess if the key is responding well, the machine will be on, or else will be saying, like for example, if we switching on the machine, the backlight, if the backlight is not working, then the same issue will be there. But before that, what we can do is just remove this keypad and see what is inside, and if there is any dust or corrosion is there, we can clean it up and close it again and see what is happen. What will happen, and let's see. So this is the thing I told. If there is any corrosion or something, it won't work. But now this keypad is clean, so no need to worry about it, and these things are also fine. So I'll just clean it up and put it back to the machine and see how it responds. So after cleaning, it is working, but display is not coming. Let me switch it on again. Yes, it is coming and key is responding well. So the problem is with something else. See? Key is responding. So the problem might be with display IC or display itself. So I'll open this up and see under the thermal cam for any heating spots is there or not. If it is not there, we'll check that display IC and then see what will happen. So first remove this display and see. And when I check this display deeply, you can see some marks, like it was made by physically or something. You can see it here. So there might be a chances with the display itself. If it's so, we have to change this entire display. So, and I didn't find any heating spot here, because as my earlier videos, if the display is in complaint, there will be a feedback in heat, like in this display IC or caps or comparators or something. will be heated like 135 degree to 200 degrees Celsius. So it is not happening. It wasn't happening. So there might be chances with the display itself, because display is broken, physically damaged here in this lower part of display. So next step what I'm going to do is just order the display and see, or else if I have a same machine, just interchange the display and see what will happen. If the display is not if the display is working, then we will order one new display and change it back to the machine. And okay, whatever it is, we find the complaint with charging circuit and we rectified it, so that is enough. So the problem was rectified with the charging circuit, because customer told the company people asked them 45,000 for the main board, because they said the charging issue was there, and they said, the company people said there will be a board issue, so they have to change the entire board. So it will take 45,000. And then customer approached me and I said, okay, let's try it. And yes, we finished that charging circuit issue. And second thing is, they might be hit with that display might be hit with something like a sharpen, like whatever, scissors, or there will be multiple chances of hitting that display. And the display, and second thing is, the power button wasn't responding, and we cleaned the power board, that keypad, and it is working now. So third thing is the display, and as I told you earlier, this will be a physical damage, so we should change it. Before changing the entire display, I should confirm with another board or another machine with the same display, and put it here. And if it's fine, then we will order a new display, which will take like 6,000 to 9,000. By the way, we reduce the customer's expense by making the small repairing on the board. And I'm going to end the video right here, and don't forget to like and subscribe, and we'll see you soon with some other videos. Bye.